Hi everyone, this video is on exercise 9F question 11. So we have the equation x is equal to r cos y squared, and we want to show that the derivative is equal to this. So the first thing that we can do is trying to write the function in terms of x, because the given function is in terms of y, and we don't want that here. So the first thing that we can do is to take a square root. So if we take the square root from both sides, we are going to get a square root of x is equal to r cos y. And the reason that here is only positive root x, not negative, is because if you know the range of r cos y is 0 to pi. So the range of r cos y, this function has the range 0 to pi, which is positive, so that the value of x can't be negative. So this always, the output of here is always positive. So that's why we only take the positive of the square root. So it's very important to remember these kinds of properties of functions. Now, so here we have r cos y, and we can take the cos of both sides. That allows us to have cos root x is equal to just y, because cos and r cos cancel each other out. And now it's a very standard differentiation, because we just need to use the product rule at this point. So sorry, I meant the chain rule, not the product rule. So dy dx is equal to the derivative of inside. Remember that it's root x, so root x is just equal to x to the power of half, and its derivative is basically equal to half x to the power of minus a half, or in a nicer form is half times 1 over square root of x. So in this case, the derivative of inside is 1 over 2 root x times, now we need to find the derivative of outside. So outside is clear because it's cos of something. So cos in general differentiates to minus sign. So it's going to be minus sine root x. So you just chain rule. Okay, so at this point, what we have, we found the value of the derivative. The derivative is equal to minus sine root x over 2 root x. But we are not done yet, because the question is asking us to give in this form. We can already see that the denominator is the same, and also we have this negative sign. The only difference is the numerator, because our numerator is sine root x, but in the question we are expected to have the square root of 1 minus cos squared square root x. So it might look a bit complicated, but it's actually just a matter of using the most basic identity in trigonometry, which is sine squared x plus cos squared x is equal to 1. And this is a very typical technique, that there are many cases that we want to use the identity and write cos in terms of sine, or vice versa. So in this case, remember that we have sine, so we want to find a way to somehow write sine in terms of cos. So that means we can rearrange the identity. Sine squared x is equal to 1 minus cos squared x, and obviously we take the square root. So sine x is equal to the square root of 1 minus cos squared x. And again, the output here is not negative, so it's either positive or 0. So that's why we have just the positive square root, not the negative. For example, 1 minus cos squared x is always a value between 0 to 1. Now here we need to use this trick, but there is only a very small difference, and that is we have sine root x. So that just means all the things we have done here still holds, but instead of having sine x or cos squared x, we just need to write down root x because the inner function is root x, is not x. But that doesn't change the result that we got here because we need to use this result. So in order to use that for this question, we are going to use sine root x is equal to the square root of 1 minus cos squared root x. So that's what we need for this question. And now all we need to do is basically substituting into the derivative and rearrange that if it's needed. I don't think there is any need of, sorry, not rearranging, maybe simplifying, let's see, but I don't think, because there is no need of that. Okay, so divide x is equal to minus, we said the denominator doesn't change because that's the same as the question, and then for the numerator, instead of writing sine root x, we just use the result that sine x is equal to this, and in this case it's sine root x is equal to the square root of 1 minus cos squared root x. And yeah, so that's exactly what we were asked to prove. Okay, that's it for this video, and thank you for watching.